Hi and welcome to the part 5 and the final session of this Docker training module. So if you have reached this point, then I think it is really commendable because you must be clear with all the fundamentals and basic understanding of Docker. You must be familiarized with almost all the basic commands in Docker using which we can perform different operations like creating image, creating containers, removing containers, creating a Docker file, creating network, volumes, and all such concepts must be clear to you. So now let us understand about the final two topics in this Docker training module, which is Docker Compose and Docker Swarm. So first we will understand about Docker Compose, and also we will see the hands-on where we will be creating containers using Docker Compose, and we will be seeing how to write a YAML file, and using the Docker Compose YAML file how we can create containers and how we can scale up the containers and also scale down the containers. So these are some basic operations that we are going to see on Docker Compose. But there is one thing here, that Docker Compose is a very vast concept because you have so many different possibilities that you can execute using Docker Compose. So inside the YAML file you have many different tags and you can perform various operations. So Docker Compose itself, or the YAML file construction itself, is a very large topic, but in this training module we will be looking at how to work with Docker Compose, how to create a YAML file, how to write a very basic YAML file where we can pass some basic instructions to create a container. So in this case we will be using the same web application that we used in the last video from my public repository, and we will be creating the web application and then we will try to access that particular web application. And after getting the idea of the basics of Docker Compose, I highly recommend you to explore more tags in the Docker documentation and try to understand what are the different possibilities that we have and what are the different operations that we can perform using various keywords which we can use to create instructions inside the YAML file, and then we can create containers from the YAML file, which is nothing but the Docker Compose. And after completing Docker Compose, we will be looking at the Docker Swarm. So Docker Swarm is a little large concept, so we will see it separately, and that is something that we are going to use a lot in Kubernetes, which is the architecture of manager and worker nodes. So those concepts we will be understanding in the Docker Swarm part of this video. Having said all this, I hope that now it is clear what you can expect out of this video. So we are going to discuss both these topics, Docker Compose and Docker Swarm, in detail. So let us begin. So as you can see here that we are in our EC2 instance, which is nothing but the Ubuntu EC2 instance. And also I have installed Docker into this EC2 instance. So you can also install Docker first. So the first thing that we have to understand about Docker Compose is why is Docker Compose is used. So before understanding what is a Docker Compose, first we will understand why is Docker Compose used. So you would have noticed by now that in the last few videos, we understood about how to create custom images, we understood about how to create containers, and also we saw that how we can create multiple containers or maybe multiple instances of the same container from a single image. So all these things we saw, but you would have noticed one thing, that we were creating multiple instances of the container by executing the docker run command every time, which means that whenever we want to create multiple instances of any container, then we have to execute a separate command every time and we have to create that container from a particular image. But when it comes to Docker Compose, it basically helps us create multiple instances of containers in a single command, because Docker Compose is nothing but it is like a service which will have all the configuration which is required for our containers to run. So you can basically think of it like this. For example, if we had 5 containers which provided a particular service, which means that in order for a particular service for us to run, we need all these 5 containers which host different applications. Now in a normal scenario, all these 5 containers will have its own life cycle, which means, for example, if we want to bring this service down or bring all these containers down, then we have to individually bring down all these containers one by one. And after that, if we want to bring these containers up again, then we have to individually bring them up. And this is where Docker Compose is very helpful. So when it comes to Docker Compose, we can simply bundle all these containers as a single service, which means that using a single Docker Compose command, we can bring all these containers up. And similarly, if we want to bring them down, then we can do it by a single Docker Compose command, which is Docker Compose down, which we will see shortly. So basically, you can consider Docker Compose as a tool to run multi-container Docker applications. And this is achieved by writing down all the instructions or configurations inside a YAML file. So basically all the application related configuration we can store in a YAML file, and using that Docker Compose YAML file, we can create our containers. And once we have feeded all our instructions inside the YAML file, then we can create our service, manage it, and also remove the service whenever we want, which means that basically we can manage the complete life cycle of our service using a single Docker Compose. Apart from this, we can also scale our service. For example, if we want a particular container to have more number of instances, because suddenly if we receive lot more traffic than expected, then we can basically scale up our containers using a single command. So that is also possible. And on the contrary, if we want to decrease the number of instances of a particular container, like for example, if we have 5 instances of a container, then we want to reduce it to maybe 2 instances, then that also can be achieved using the Docker Compose command. But we need to be careful on one aspect when it comes to scaling up and down our applications or containers. That is, the Docker host must have enough resources to support all those scaled up containers. So that is something which should be taken care during the design phase of our applications. But apart from that, using Docker Compose, we can scale up and scale down our containers. That is something which is possible. But yes, in terms of the resource management, we have to plan it accordingly. So now let us explore all these concepts that we just understood. So first we will install Docker Compose. So in order to install the Docker Compose into your Docker host, you can refer the documentation. So we are in the Docker official web page. So if you see here that we have instructions to install Compose. So if you click this and if you come down, then as you can see that for different operating systems, we have different set of instructions. So since we are in the Linux or the Ubuntu operating system, we will click Linux. So here is the command. So you can simply copy paste this particular command. So as you can see that Docker Compose is getting installed, allow it to complete. So Docker Compose is now installed. Now the next command to execute is this one, which is the chmod command. Basically it will change the permission for this particular Docker Compose file in this path, user local bin. So all we have to do is simply copy paste this particular command into your Ubuntu server and just execute it. So at this point our Docker Compose has been successfully installed in our Docker host. So now we can validate the installation, and that is by using the version command which we usually use in Docker to validate any installation. So we can say docker compose -- version. So if we execute this command, then as you can see that the version of Docker Compose is coming in the output. So the version of our Docker Compose is 1.27.4. So now since we have completed installing the Docker Compose in our Docker host, let us move on and create the YAML file which we will be using in order to pass all the instructions or the configuration of our service, or in other words we can say our application configurations. So in order to create a YAML file, let us use the YAML file which is available in the Docker web page. So if you go to the Docker official web page, and then if you go to the overview of Docker Compose section, then as you can see here that they have given a reference or a sample YAML instructions. So we will use the same. So we can just simply copy this one and we can go back to our instance. So here we will first create a YAML file. So we will give vi docker compose .yaml. So now we are inside the YAML file. So let us just copy paste the sample YAML instructions that we copied from the Docker web page. So we can click paste. So as you can see here that this is how we can write our instructions inside the YAML file. So the first instruction is the version, which is nothing but the version of this particular YAML that we are using, or basically you can also say that the version of the service that we are about to create. And the second tag is the services tag. This is where we define the configuration of our application. So we are going to make few modifications in this. For example, we will remove this build, and instead of the build we will write image that we are going to use in order to create our container. So we can give the tag as image, and then here we can write the image that we are going to pull in order to create our container. So we will be using the same image that we used in the last video. If you remember that we pulled a particular custom image from my public repository. So we can just use the same naming convention, which is my username slash and then the name of the image, which is web app. So we will be using the same image, and you can also give the same name because this image is available in my public repository. So you can also use the same username and slash and then the name of the image. And if you remember that in the last video we saw that this particular web application was accessible in our HTTP default port, which is 8080. So we will give the same port here as well. So we can just say 8080, and then we have the volume configuration. So we don't want this particular line of instruction here. So we can simply remove this. So as you can see here that we are able to set the image using which we want to container. We are able to set the port using which we can access the application. We are able to define a volume where we would want our logs to get stored. So as you can see that it will automatically create the volume with this name, which is log volume 01, and it will store all the files which will be there in the var log folder inside our container to this particular log volume, which means that later when you will be moving your containers down or up, it won't have any impact on the data inside this particular volume. So you can have such configurations as well. Similarly, it is creating links between all the Redis containers that we are going to create as part of this service. So if you are not aware about Redis, Redis is basically an application using which you can just store some small amount of data. So Redis basically stores all your data in a data structure, which is nothing but a key value pair data structure. So in different programming languages, we have different key value pairs. Like for example, in Java, we have hash map, and in Python, you have dictionaries. So all these data structures that we have, which stores the data in key value pairs. Similarly, in Redis also, you can just store the data which is coming from your web application in just a key value pair format. So this is specifically for demo use. It is usually not used for any major commercial purpose, but Redis is something that you can use for temporary purpose just to test your application. So here we will be just using this particular Redis application in order to just store our data, but that is just for demo purpose. And then as you can see that we are creating a link between all the Redis containers, which means that each Redis container will be able to communicate with each other. Which means that if you are inside a particular Redis container, then you will be able to ping other Redis containers. And I hope that you remember that in the last video, we discussed about this particular links keyword in our Docker run command, using which we were able to create multiple containers and we were able to establish connectivity between the containers. And we also pinged all the containers from each other. So using the links keyword, we can simply establish connectivity between different containers. And this particular keyword we also explored in the last video. And finally, we have the Redis keyword where we are just giving the instruction of image. So using which image we have to create the Redis containers. So that is given here in this instruction. And finally, we have the volumes keyword where we are just declaring that this is the particular volume that we would want when the service gets created. So as you can see in this particular YAML file that we have almost passed all the required instructions that we will need in order for our service to function, which means that we are giving instruction of which particular image we have to pull, on which particular port we have to access the application which is inside the container. Then we are giving our volume information. Then we are giving the Redis information where we are establishing connectivity between all the containers using the links keyword. And finally, we are also giving instructions to create the volume. Similarly, you have many different possibilities or many different instructions, or you can also create your own custom instructions or custom tags using which you can write different kind of instructions inside the YAML file. So this is a very basic example. Now we will save this particular YAML file and then we will create our containers. So first let us save this. So now we have saved our Docker Compose YAML file. So now since our Docker YAML file is ready, we can directly create our service by using the command docker compose up and then -d. So it is as simple as this. So using the docker compose up command, we can simply bring our service up, which means that after executing this command, all the instructions that we passed inside the YAML file will get executed and the entire service will be created, which means that first the web application image which is stored in my public repository will get downloaded. Out of that, a web application container will be created, and then the Redis image will be downloaded, and then the Redis container will be created. Along with the container creation, we will also see that a Docker volume would have got created, which we have passed as an instruction inside our Docker Compose YAML file, which is the log volume. And that particular volume will be mapped to the var log path inside our container. So all this will happen only with a single command. So let us execute this particular command. So as you can see here that the images are getting pulled. So the Redis image got pulled. Now the web application image is getting pulled from the public repository. Allow it to complete. So as you can see that the Docker Compose service is now created. Now let us validate whether all the instructions got successfully executed or not. So first thing is that we will check whether our images got downloaded successfully or not. So we can execute the command docker image ls. So as you can see in the output that both the Redis image and also the web application image from my public repository got downloaded. And if we now execute the command docker ps, then as you can see that two containers are created here. One is the web application container and second one is the Redis container. And also if you notice that the port forwarding has been successfully implemented in the web application container, which means that we will be able to access this particular web application using the port number 80. We will try that shortly. And also in order to store all the data which is coming out of our web application, the Redis container is also up and running. Now let us see whether the volume got created or not. So if we execute the command docker volume ls, then as you can see here that log volume 01 also has been created, which means all the instructions that we passed inside our YAML file has been successfully implemented. So now if we want to bring down the entire service, then all we have to do is we can execute the command docker compose down. So if you execute this command, then automatically the containers which are running will come down, but the resources which were used to create the particular service will not be removed. For example, the resources were nothing but the images and the volume which got created. So those will not be removed. Only the running containers will come down. So we will execute this command shortly to validate whether it works or not. But before that, I just want to show you that we are able to access our application using the port 80. So if we go back to the Chrome, and if I go to my EC2 instance, I will copy my public IP address, and then if I just copy paste it here, then as you can see that our web application is accessible. So you could imagine that just using a single command docker compose up, our entire application is up and running. This is why docker compose is so powerful, that just using a single command you can completely bring a service up and running. And similarly, by using the down command, you can just bring down the service. So now let us go ahead and bring down docker compose service and see what happens. So we can execute the command docker compose down. So as you can see that the running containers are coming down now. So both the containers got stopped and also they are removed. So if we go to docker ps now, then as you can see that none of the containers are running anymore. But if you notice here that the images that were downloaded are not removed from the docker host yet. And also docker volume which got created will also be retained. It won't be deleted. So if you are bringing down your service, it won't have any impact on the resources which were created in order to make the service up. Only the application or the containers will come down if you bring down the service. So this is something very good if you think about it, because if your resources are removed, then it will sometimes mean that your critical data might also remove along with the volumes. So Docker Compose is designed in such a way that when it is coming down, it won't have any impact on the resources of the Docker Compose. Only the impact will be on the applications or the containers which it will bring down by using the Docker Compose down command. So I hope that this is clear. Now let us bring our service back so we can use the same command docker compose up -d. So now if you noticed that the service came up very quickly, and this is happening because all the resources are already available in the Docker host, which means it did not have to re-download the entire Redis and also the web application image from my public repository. Everything was available. In fact, the Docker volume was already available. So it did not have to create all the resources again. All it had to do was just bring those containers up and running again. So if we go to docker ps now, then as you can see that both the containers are up and running again. Now let us do one thing. Let us scale our application. Now, for example, if we want to scale up our web application, then we can use the docker compose scale command. But we will get an error here, and I want you to see this particular error. So if we execute the command docker compose scale, and then we can write the name of our service, which is web. Since this is a web application, the name of the service is web. And if you remember in the YAML file also, we had this particular tag web. So that is the name of this particular service, which is a web application. And now if we want to increase the number of instances of this particular web service, then all we have to do is, after writing the name of the service, we can give equals, and then we can write the number of instances that we want. For example, if we want to increase it from 1 to 3, then we can say 3 as the number of instances. So now if we execute this command, then we will get an error. Now notice that particular error. As you can see here, we are getting an error which says that bind of the port 80 is not possible. So if you think about it, that a particular container is already mapped with the Docker host port 80, which means that the containers 80 port is mapped to the Docker host 80 port, and that is happening because of the port forwarding that we have done in our YAML file. So since a particular container is already mapped to that port, it would simply mean that you cannot create another container which will map to the same port of your Docker host. And that is the reason that whenever you have created a particular container using port forwarding, you won't be able to scale it up. And that is the main reason I showed you this particular error, that whenever we have used port forwarding on a particular container, we won't be able to scale up because we would have already given a specific port to the of the container to the Docker host. But we can definitely scale up the Redis container here. So if we give the same command on the Redis, then as you can see that 2 more containers got created. So now if we execute the docker ps command, and as you can see here that there are 3 instances of Redis containers are running. So using the docker compose scale command, we can scale up the number of containers, and similarly we can scale down, and scale down is also using the same command. So in order to scale down, we can use the same command, which is docker compose scale. So earlier we had 3 instances, now we can reduce it to 1 instance. So if you give Redis equal to 1, then it will simply bring down 2 instances, and if you go to docker ps now, then as you can see it is back to a single instance. So this is how we can scale up or scale down any number of containers using docker compose. So this is a very powerful feature in docker compose, that if you have sufficient amount of resource available in your Docker host, then you can scale up your applications or the number of containers based on the traffic requirements. And similarly, if you want to scale down, then using just the same command, you can scale down the number of containers as well. So I hope that the concept of Docker Compose is clear now. So this was the basic explanation about Docker Compose. Now, if you think about it, the YAML file, the instructions that we are passing in the YAML file, we have many different possibilities, and there are different operations that we can perform inside the YAML file. So in order to understand those instructions, you can refer the Docker documentation in the Docker official web page. But by now you must be clear that how we can use Docker Compose to create an entire service of multi-containers application, and how we can scale them up, scale them down, how we can bring down the entire service using a single command, and how we can create a Docker Compose file, which is nothing but the YAML file, and how we can write down our instructions inside the YAML file. So having understood about Docker Compose, now let us move on to Docker Swarm. So the first thing that we need to understand about a Docker Swarm is, of course, what is Docker Swarm and why is it used? So this is the architectural diagram of a Docker Swarm, where you can see that there are some manager nodes, there are some worker nodes, which are arranged together in order to function as a clustered architecture. So a Docker Swarm is a group of either physical machines or virtual machines that are running the Docker applications. And all these physical or virtual machines has been configured together in a cluster. And in this cluster, we will have certain nodes defined as manager nodes, and we will have certain nodes defined as worker nodes. So using the manager nodes, we can completely manage all the operations that we are performing in all the worker nodes. This can be extremely useful if you think about it, because for example, in usual cases where you have 4 to 5 containers, then it will be easier to manage all the containers because the number is very less. But in some cases, you may have containers up to 100 or 200, and when you are having such high amount of containers to manage, then it is not easy to manage all those containers by individually handling its life cycles and also handling its operations. So in such cases, if we use Docker Swarm, which is nothing but an orchestration tool, we can have a clustered architecture where we can manage the operations undergoing in all the worker nodes using the manager nodes. So one single manager node can handle all the operations and the life cycle of multiple worker nodes. And in this diagram, as you can see, that each manager node is connected to multiple worker nodes, and each manager is responsible for its own worker nodes, which means the worker nodes to which a particular manager is connected, it is responsible for its life cycle and also all the operations. So basically, a Docker Swarm is a container orchestration tool which allows the user to manage multiple containers deployed across multiple host machines. So in this particular cluster, the primary function of the manager node is to assign tasks to worker nodes in the swarm. And also the manager node is responsible to carry out all the managerial tasks, which means that the tasks where any decisions has to be taken, all such tasks which is required for the swarm itself to operate. So such tasks also is handled and managed by the manager nodes only. And in a particular Docker Swarm, we can have 7 number of manager nodes. So we cannot have more than 7 number of manager nodes. That is the maximum number of manager nodes that are available in a particular Docker Swarm. And then we have the worker nodes. So in a Docker Swarm, the worker node basically functions by just receiving and executing the tasks that are allocated by the manager nodes. So whatever tasks and instructions that are passed by the manager nodes, they are simply being executed by the worker nodes, and that is the only function that a worker node has. And also in Docker Swarm, by default, all the manager nodes are also worker nodes, which means that manager node can also function as a worker node itself. So which means that a manager node can also receive instructions and it can execute various tasks and operations that usually a worker node can perform. So from this diagram, as you can see that each manager is connected to various worker nodes, then there are different functions that a manager has to perform in order for the entire cluster to work properly. For example, if a particular worker node is down, then what actions has to be taken, how to distribute the traffic, how to distribute the creation of containers. There are many different operations that a manager has to manage in order for the cluster to work properly. So all these communications or all these algorithms or decision is done by the Raft algorithm, and the communication between one particular manager to another manager is using the Raft algorithm. Now using this algorithm, all the decision making is done across the cluster, and the manager also has a leader node, which means that if you have multiple manager nodes, then one of them has to be the leader, and the leader node is the one that logs all the actions that are done in the cluster. And using the Raft algorithm, the swarm ensures that the leader's logs are replicated within each manager. So which means the logs that are currently existing in a leader node is automatically replicated in all the other manager nodes, so that if a situation arises where leader node has come down or is unavailable, then same set of operations and tasks can be easily taken care by another manager node, which can take the next leader position. So at any given point of time, the Raft algorithm ensures that each manager in the Docker Swarm has the same version of the logs, which basically means that it ensures high availability of all the managers in the Docker Swarm. So now let us move on to see how we can create our host machines in AWS account, and then we will create our manager node, and then we will create the worker nodes, and we will link them together to form a cluster. So before creating the cluster, I want you to have a look at the Docker service architecture, which explains how the Docker Swarm manager and the worker node function together. So as you can see that we have different components available inside the Docker Swarm manager, which is nothing but the API component orchestrator. We have the allocator, dispatcher, and also the scheduler. And similarly in the worker node, we have the worker and the executor. So the first thing that you notice in the Swarm manager is that all the components are working together using the raft algorithm, and each component has its own function. For example, the API component accepts the commands and creates the service objects. So from the Docker client, we will execute certain commands in our Swarm. So all such commands will be received by the API component of the Docker Swarm manager, and it will be executed in order to create service objects. Now the service objects are nothing but the containers. And then we have the orchestrator, which basically creates the tasks for the service objects. And then we have the allocator, which basically allocates the IP addresses to various tasks. And then we have the dispatcher, which basically assigns a particular task to a particular node, which means nothing but the worker node. And finally, we have the scheduler nodes. And this particular component basically instructs a worker node to run a particular task. So these are the various components which comprises the Swarm manager node. And then we have two components in the worker node, which is worker and the executor. So as you can see that the worker component connects to the dispatcher component of the Swarm manager and checks for any assigned task. So if you see the functionality of the dispatcher, it basically assigns a particular task to a node, and the worker component inside the worker node validates and checks the dispatcher component of the Swarm manager in order to see whether any task has been assigned to that particular worker node or not. And similarly, we have the executor component which executes the task which has been assigned to the worker node. So these are the various components that are available inside the Swarm manager and the worker node, and this is how the manager and the worker node functions together inside a cluster. So having understood the Docker Swarm service architecture, let us move forward and start creating our cluster. So the first thing is we have to create 3 EC2 instances in the AWS account. So since we have already seen the steps on how to create the EC2 instance in the part 1 video, I'm just continuing with already created instances. So you can take your time, create the EC2 instance, and if you are stuck anywhere, then you can use the part 1 video as a reference to create these EC2 instances. So here, after creating all the EC2 instances, you can simply name one of the EC2 instance as the manager and other two EC2 instance as the worker nodes. So you can say worker 1 and worker 2. And there is no other difference. You have to just create 3 EC2 instances. Like there is no specific EC2 instance configuration for a worker node or a manager node. They are just the same node, which means that you can just create one single certificate and you can access all the 3 nodes. So there is no such AWS wise difference between these EC2 instances. It's just that we have simply created 3 instances and we are going to use them as our Docker Swarm nodes, where one will act as a manager node and other two will act as a worker node. So once you have completed creating the manager node and also both worker nodes, then you can access those nodes from the MobiXterm tool. So open up all the 3 servers and then perform the same actions that we did in the part 1 video, where we first executed the apt update command, then we installed the Docker. So finish that process. And if you have any doubts or if you are stuck anywhere, then please refer the part 1 video where we have created an EC2 instance and then we have installed Docker from scratch. So once all the 3 EC2 instances are up and running, and also you have completed the installation of Docker, then you can select any one node and you can change the host name of that particular node as master, and then you can name the other 2 nodes host name as worker 1 and worker 2. So in the part 1 video, we have also covered how we can change the host name of a particular Ubuntu server, so you can refer that. So remember that one of the EC2 instance host name should be master and the other 2 EC2 instance should be worker 1 and worker 2. So after completing all these configurations, now we can initiate creation of our Swarm cluster. So we can give the command Docker Swarm init. So if we execute this command, then automatically the server in which we are executing this particular command will become the manager. So as you can see in this output that it says Swarm initialized, current node is now a manager. And also it gives a Docker Swarm join command using which you can make other nodes or other available nodes as the worker node of this particular manager node. So if you execute this particular command in the other two EC2 instance that you have, worker 1 and worker 2, then automatically those nodes will become the worker node of this particular manager node. So now let us execute this particular command in one of our worker nodes. So as you can see that this node is now the worker node of the Swarm cluster, where it is mapped to the manager from which we copied this particular command. And similarly, let us execute the same command in the other EC2 instance as well. So as you can see that this node is also one of the worker nodes of the manager node. So this is how we can create a cluster. So first we have to execute the docker swarm init command in our manager node. So in any node where we execute that particular command will automatically become the manager node, and then it will provide a particular join command using which we can make other nodes as the worker node of that particular manager node. So now if we execute the docker node ls command, then as you can see that we have three nodes in our cluster, where one of them is the master node and other two are the worker nodes. And there are some information which are given here, like for example the ID. So you have the ID of all the nodes available, and then we have the host name given for each of the nodes, and then we have the status of the nodes which is ready right now, and then the availability is active, so all of them are active nodes, and then we have the manager status. So the manager that we currently have is also happen to be the leader of the manager, because of course we have single manager, so it automatically becomes the leader. So which means that if you have multiple managers in your cluster, then one of them will be leader at a particular point of time. Now at this point of time you may get a question that what if I lose this particular command that is provided by the manager? Now we have a docker swarm join command using which we can create other nodes as the worker node of this particular manager. What if we just lose this particular window and we lose this particular command? So in order to find this particular command from a manager, all you have to do is execute the command docker swarm join -token and then space worker. So if you execute this particular command in your manager node, then automatically it will provide you with the command using which you can add more worker nodes. So as you can see in this particular output that the docker swarm join command is provided by this manager for you to create more worker nodes and attach more worker nodes to this manager node. Now what if you want to join more manager nodes to this particular manager node? For that also we have a command. So in order to get the docker swarm join command to join another manager node, we have to execute the command docker swarm join token, and instead of worker this time we have to give the manager. So if you see in the output, we have the docker swarm join command using which we can link other manager nodes or other nodes as a manager to this particular manager. So I hope that these two commands are clear. This will be very helpful for you to create more worker nodes and manager nodes and add it to your cluster. So if you want to check whether a particular node is a master or a worker node, then you can go to docker info command, and here also you can check whether docker swarm is active in the docker host or not. So as you can see that swarm is active, which means docker swarm is active in this particular docker host. And also as you can see that the is manager tag is true, which means that this particular docker host is the manager in the docker swarm cluster. Similarly, you can find other information like the default address pool, then you have the cluster ID. Also it shows how many manager nodes are there. So as you can see that manager node is 1 and the total nodes in the cluster is 3, so it is given in the nodes tag. And also you have information like node address, and apart from this we have all other details related to the docker engine. Now if we execute the docker info command in the worker node, then in the output you can see that the is manager tag is false, which means that this particular node is a worker node. So any node where the is manager tag is false in the docker info, it will be a worker node. And finally let us execute the docker info command in worker 2 also. So here if you see, again we have the is manager tag as false, so which means that any node where the is manager tag is false, it is nothing but a worker node. Now for example, if we want to make a worker node come out of the docker swarm cluster, then we can give the command docker swarm leave in the worker node. So if you give this command in the worker node, then as you can see that node left the swarm, which means that the node has been removed from this particular cluster. So now if we go to the master and give the command docker node ls, and as you can see in the output that all the three nodes are in ready state, because it is taking some time for the worker node 2 to come out of the cluster. So now as you can see that the worker 2 has come down, the status is down, which means that the worker 2 is out of the cluster. Now since the status of worker 2 is down, it won't receive any further instructions from the manager to perform any operations. So now if we want to remove this particular worker 2 completely from the cluster, then we can give the command docker node rm, and then we can write the name of our worker node, which is worker 02. 2. So as you can see that worker 2 has been removed from the cluster. Now we will find only master and the worker 1 node in our cluster. So this is how we can first bring our worker node down by giving the command docker swarm leave in the worker node, and then from the manager node we can completely remove the worker node from the cluster using the docker node rm command. So now if we go to worker 2 and if we check the docker info command, then as you can see that now swarm is inactive, which means this particular worker node is out of the docker swarm, and also it does not have any parameters related to the swarm, like for example is manager tag. Now you will find that in the docker info command the is manager tag is not available, so which means that any node, if it is added to a particular docker swarm, then automatically certain tags will be added in the docker info command. So since this worker node has been removed, all such tags has been removed which is related to the docker swarm configuration. And similarly, using the same list of command, I'm going to use them to remove worker node 1 from the docker swarm. So as you can see in this output that worker node 1 also has been removed from the docker swarm. So that is why you are not able to see the worker node 1 and worker 2 in the docker node ls command. So now let us go ahead and add those worker nodes back to our docker swarm. So we can use the same command docker swarm join token, and then we can pass the worker. So as you can see that now we have the token available using which we can add another worker node to our docker swarm. So we can copy this, and then in the worker node we will simply paste it and execute this command. So now this particular worker node 1 has been added to the docker swarm, and similarly we can do the same in worker node 2. So both the worker nodes are now back and it is added to our docker swarm. So now if we execute the command docker node ls in our manager node, then as you can see that all the worker nodes are now added back. So this is how you can remove worker nodes from the docker swarm, and also you can add it back to the docker swarm. So now let us move on to see how we can inspect all the configuration in the worker nodes from the manager. So we can use the command docker node inspect, and then we can write the name of the worker node. For example, if you want to check the configuration of worker 1, then we can say worker 1. So here you will find all the information about the worker node, like for example, or the network info, worker ID, volumes, what is the creation date, various resources that is being used by the worker, and what is the current state of the worker, what is the IP address of this worker. So all kind of information will be available in the docker inspect command. So just how we used to inspect the containers or volumes or networks in the previous video, similarly we can always inspect any worker node or even the manager node using the docker inspect command. And also if you want to really dig in and explore all the parameters that are given in the docker inspect command, then you can always refer the documentation. So all the information is available in Docker's official webpage. So now let us move on. So if you are in a situation where you want to promote some of your worker nodes as a manager node, then is that possible in Docker Swarm? And the answer to that question is yes, that is very much possible. So if you want to promote all your workers node to the manager node, then you can use the command docker node, and then you can write promote and space, and then you can pass all your worker nodes name in sequence. So for example, if we want to upgrade or promote our worker node 1 and worker node 2, both of them at the same time, then we can write worker node 1 and space and then worker 02, which is the name of our second worker node. So if you execute this command, then as you can see that it is moved to the manager role now. So if you look at the output of this command, then it says node worker 1 promoted to manager, and also node worker 2 is also promoted to manager in the swarm. So now if you see the docker node ls command, then all the three nodes are now managers in the docker swarm, which means that one of the manager is the leader and other two managers are reachable. Their status is reachable, which means that they are not the leaders, they are just managers, where all the current tasks and operations which are performed by the leader will be duplicated or replicated, so that when the leader is down, automatically some other manager can take that role and continue all the tasks and operations. So as of now, they are in the reachable state, and one of them is the leader node. So I hope that this is clear. Now if we go to worker 1 and execute the command docker info, then if you look at the is manager tag, as you can see that it is true now. So docker swarm is active and the is manager tag is true, which means this worker node is now a manager node. And as you can see that there are three managers now in our docker swarm, and there are three nodes. And also if you go to worker node 2 and if we execute docker info command, then here also is manager tag must be true. So as you can see that the is manager tag is true in the output, and the docker swarm is active, and similarly manager nodes are 3. So this is how we can convert all our worker nodes or maybe selected worker nodes to manager nodes. in a Docker Swarm. And now if we want to demote all the manager nodes or some of the selected manager nodes to worker nodes back, then all we have to do is instead of promote, we have to now use demote in our command. So we can say docker node demote, and then we can pass the list of nodes that we want to demote from the manager to the worker node. So in this case, since we want to demote all our worker nodes, so we can write docker node demote worker02 and space worker01. So as you can see that both the workers are now demoted to the worker role in our cluster. Now since the worker node 2 has been demoted to the worker role, if you execute the docker node ls command now in the worker node, it will fail because docker node ls is a command which you can execute only in your manager node. But if you see in the manager node, still the docker node ls commands work. So using this command, you can basically ensure whether a particular worker has been or a particular manager has been really demoted or not. So once you have done the demotion from the manager to worker role, then automatically you can use this command docker node ls, and then you can verify whether that node got demoted or not. But there are many other ways also, like for example, you can just go and do a docker inspect on the worker node, or you can also use the docker info command to verify this. But yes, docker node ls is also one of the commands that you can use to verify whether your current node is in the worker role or the manager role. So these were some of the fundamentals of the Docker Swarm, where we saw that how we can basically install a Docker Swarm, then how we can create a manager, then how we can create the worker nodes, and then how we can generate a particular Docker join token from the manager, and then we can link all our worker nodes to the manager. So now, having understood the basics of the Docker Swarm, we can move ahead and see how we can deploy our applications using the Docker service. So using the Docker service, we can deploy our applications when our Docker engine is running in the Swarm mode. So if you notice in the Docker info command, the Swarm tag in the Docker info command is active, which means that our Docker engine is running in the Swarm mode. So when the Docker engine is running in the Swarm mode, in that case, in order to deploy our applications, we must use Docker services. So for example, if you have an HTTP server, a database, or in fact any other type of executable program that you wish to run in your distributed environment or your cluster, then in that case we can create a service, and using that service we can basically manage our applications. And when you create a service, basically we specify what image we are going to use, or based on which particular image we are going to create our containers, which commands are we going to execute inside the running containers. And we also define certain other points, like for example the port where the Docker Swarm makes the service available outside of the Swarm. So which means that what are the ports using which we can access our applications inside the Docker Swarm from the external network. Then we can define the overlay network for our service to connect other services inside the Docker Swarm. Then we can define our CPU and memory limitations and reservations for our containers. And we can also define the number of replicas of our image to run inside the Swarm. So there are various configurations that we can do to define our service, and using which we can create our containers in our cluster. So now, having understood what a services is and what kind of configurations we can do using a service theoretically, now let us see how we can create a service, and using that service how we can bring our containers up inside a cluster formation, or basically the Docker Swarm. So first let us explore the Docker service command to see what are the different instructions available in this particular command. So we can give Docker service, and then we can say ---- help. So basically you can check the instructions in any component of the Docker using this command. So as you can see here that we have option to create, we have option to inspect, we have option to see the logs, then we have option to list out all the services that are available, then we have option to list the tasks of one or more services using the PS instruction, then we have option to remove, rollback, scale, and also update. So we can basically update our service also. So in between, if we want to make certain modifications in our service, then that also is possible in Docker service. So these are the various options or commands that are available in the Docker service command. So now let us move on and see how we can create a service, and from that service how we can create our containers. So in order to create a service, we can give the command docker service create, and then we can pass the name of the service in the --name tag. And now we can give the name as, for example, my service, and then we can write -d, which is to run all the containers which will be created out of this service in the detached mode. And finally we can give the name of the image from which we want to create our containers. So if we execute this command, then as you can see that a service has been created, and in order to check the creation of this particular service, we can give the command docker service ls to list out all the services. So as you can see here that we have our service created, and it is having one replica, which means a container also has been created for this particular service. And other tags are quite self-explanatory. tree, which we have already explored many times before in other components. Like for example, we have ID, name, mode, replicas, image, and ports. So all these tags we have already explored and understood. Now if we give the command docker ps, then as you can see that a container has been created from this particular service. So which means that the moment the service came up, automatically corresponding container also got created along with the service. So this is the benefit of using a service. So basically you can manage all the containers lifecycle. For example, if you have multiple containers as part of this service, then you can handle the lifecycle of all those containers using a single command or using the single service. So that is the main advantage of using a service in our Docker Swarm mode. So basically when your Docker host is running in the Docker Swarm mode, using the services we can create or manage the lifecycle of all our containers. And also as you can see that other tags are quite self-explanatory. For example, a name has been given to this container, which is my service, and then we have the container ID, a unique container ID. Then we have the image name from which this particular container got created. And then we have the status and created time, which is all the usual tags that we see in our docker ps command. So we have already understood about all these tags in the previous videos. So now let me show you the real advantage of using a service and creating our containers. So for example, if we remove this particular container by using the command docker rm-f, and then we can pass the container ID. So remember that this particular container got created by the service. So as you can see that the container has been removed now. But now if you execute docker ps again and again, then you will notice that the container comes up automatically, which means that the service is basically handling the life cycle of the container for us. So whenever the container goes down for any reason, it could be a manual execution to bring our container down, or it could be any other issues based on which our container came down. The reason could be anything, but the service will always attempt to bring that particular container up. So this is the main advantage of using the service, because it will automatically ensure that all your containers and all your applications are up and running. So now on top of the container which we have created from our service, let me create another container manually by giving the command docker run -it, and then we can give a name of our container. Let's say for example container 1, and then we can write -d to run our container in detached mode, and finally we can give our image name. So we will use the same image nginx. So as you can see that container is getting created, and now it has been created. So now if we execute the docker ps command, then as you can see here that we have both the containers up and running. So one container is running from our service, and one container we have manually created and which is currently running. So if we now remove the container which we created manually with the command docker rm-f, and then we can pass the container 1. So the container 1 has been removed now. Now if you execute docker ps, then that particular container will never come up, of course, because that container is manually created by us and it is not handled by any particular service. So which simply means that whenever we are having a distributed environment or a cluster environment, we should always go with deploying our applications using the services, so that the container's lifecycle is basically managed or handled by a single service. And this is especially useful when you have many containers running together. So it won't be possible for us to manage lifecycle of each container individually. So using a single service, we can manage large number of containers as a single lifecycle using its corresponding service. So currently we have our service available, and also one container is running using that particular service or within the service. Now if we want to remove the service, or what happens when we basically remove the service. So if we give the command docker service rm, and then we pass the name of our service, which is my service, then as you can see that the my service got deleted now. So now if we give the command docker service ls, then as you can see that my service got deleted. And now if you check the state of our container using the docker ps command, then as you can see that the container also got deleted, which means that when a particular service is created, along with that all the containers will get created. But when a service is removed forcefully, then all the containers which got created with the service will also get removed. So using a single command or a single service, as you can see that we can manage all our containers which is created from that particular service. So if you think about it, it is very powerful, because if you have a large application where for a single microservice you are having, like for example 30 to 40 containers, then it will be very difficult for you to manage the lifecycle of each container individually. So if you have a single service, or basically you can think of it like this, like containers are also Docker objects, right? Similarly, service is also one of the Docker objects. So using a single Docker object, you are able to control many different Docker objects. So basically all of them are Docker objects, right? So using a single service, we are able to control multiple containers. And when we are running our Docker host in the swarm mode, then it becomes absolutely necessary and absolutely mandatory to use service in order to deploy our applications. So now let us give the Docker service help command, and we will try to explore some of the other instructions that are available. So we can write Docker service hyphen hyphen help. So here, as you can see, that we have one of the options to scale our applications. So in order to explore this particular instruction, first let us create our service again. So let us use the same old command that we used to create our service, which was my service. So as you can see that the my service is created now. So if we now execute Docker service ls, then as you can see the my service has been created. And now if we execute the command Docker service scale, and then if we pass the name of our service with an extension 5, then it will basically create 5 instances of container from the same service. So as you can see here that 5 instances of the containers are basically getting created. So all the containers are created now. So using the scale command, we can basically scale up or scale down the entire service. So now if we execute the command Docker service ls, then as you can see that total 5 instances of the containers are running. So now if we give the command Docker service ps my service, then as you can see that there are 5 containers running under this particular service. And also if you notice that 2 of the containers are running in the worker node 2, 2 of the containers are running in the master node, and 1 container is running in the worker node 1, which means that when we are scaling up the service, automatically all the new containers are basically distributed across our cluster. So as you can see here that some of the nodes got created in the worker node 2, some of the nodes got created in worker node 1, and some of the nodes also got created in the master itself, because if you remember that master also is one of the worker nodes, which means that in managers also you can run your containers. And now if you want to scale down your service, then you can basically use the same command Docker service scale, and then you can write the name of the service, and then you can pass the number of instances, which for example we can give as 3. So as you can see that now 3 containers are getting created. And if you give the command Docker service ps my service now, so as you can see that earlier we had 5 containers and now only 3 containers are running. So which means using the scale command, you can either scale up or you can scale down. All you have to do is you have to pass the number of instances that we want. So I hope that now it is clear how we can scale up or scale down our containers using the services. One more thing that I wanted to show you is that if you want to create your service only for the manager nodes, for example, if you want to create maybe 3 to 5 containers only in the manager node, then in that case, that is also very much possible using the Docker service command. So for example, if we want to create 3 Nginx containers in our manager node, then we can give the command Docker service create, then the name of the service, and then we can write the number of replicas that we want for our service. And finally, we can give the constraint tag, where as you can see that we have given node role as the manager, which means all the containers that are going to be created out of this particular service will be created in the manager node only. So this is how you can basically restrict the creation of containers. So earlier we saw that when we executed the Docker service create command, then the containers basically got distributed across the cluster. So some of the containers got created in the manager node and some of the containers got created in the worker node. But if you want your particular service or the containers created from the service to be created in only particular node, then that is very much possible using the constraint tag. So now if we execute the Docker ps command in your manager node, then you will find that all the containers will get created in the manager node itself. So you can do it by yourself. Just to keep the video length in control, I'm skipping the steps that you can perform on your own. So now let us go ahead and remove this particular service. So we can give the command Docker service rm, and then we can write the name of our service, which is my service. So now this particular service has been deleted. Now in order to create the containers only in the worker node, all you have to do is use the same command and just pass worker in the constraint tag. So in the name.role, we will write as worker. So now if you see that the containers will get created only in the worker nodes. So basically the containers will get distributed across worker nodes. So for example, if you have 3 or 4 worker nodes, then based on the number of replicas you have given, it will automatically get distributed across your worker nodes. So this is how we can basically restrict the creation of containers in our cluster. So either we can select the node role as the manager or the node role as our work. And based on the constraint, automatically the containers will be created in the corresponding node role, either in the manager or in the worker. So I hope that the concept of how we can constrain creating our containers across the manager and the worker node is clear. Now let us move on to see how we can do port forwarding while creating a particular service. So in order to do port forwarding, we can use the same tag that we used to use earlier. So if you want to create a service with a port forwarding of 8080 for an Nginx web server, then you can give the command docker service create. Then you can write the name of your service in the hyphen name tag, and then you can write -d in order to run your containers in detached mode. And finally, you can give -p, and then you can pass the containers port along with the docker host port. And finally, you can write the name of the image. So now as you can see that a service has been created, and along with the service, the container also would have got created. So if I go back to my AWS account and copy the public IP address of this particular EC2 instance, and then if we go to our browser and then if we give this IP, then as you can see that we are able to access our Nginx server or the Nginx web server. So this is how we can do port forwarding in services also. So which is same as how we did our port forwarding in usual containers, where in the docker run command we used to pass the -p command and then we used to do the port forwarding. So it is the same process that we can use in order to create services with port forwarding. So I'm concluding this video now. So in this video we understood about how we can use Docker Compose, where we wrote all our instructions inside a YAML file, and using that YAML file we created our custom image, and from the image we created containers. And basically using the Docker Compose we were able to manage the life cycle of our containers using a single command, which is docker compose up, in order to bring our containers up and running, and also using docker compose down we were able to bring down all our containers. So using Docker Compose, we saw that how we can basically create and also manage our containers lifecycle. And then we moved on to see the concept of Docker Swarm, where we installed Docker Swarm in our Docker host and made our Docker host run in the Swarm mode. And then we understood about how we can create a manager node, how we can create worker nodes, how we can set a particular node as a manager node using the Docker Swarm init command. And then we saw that how we were able to join other nodes to the manager node as a worker node by using the token provided by the manager, which is nothing but the Docker Swarm join command. Using that command, we were able to execute the command in other nodes, by which we were able to make other nodes as the worker node of the manager node. Also, we explored how we can remove a particular worker node from the cluster by using the docker node rm command. And then after removing the worker node from the cluster, we also saw that how we can recreate the Docker Swarm join token from the manager, and then using that command we joined the worker nodes again back to the manager. So these were some of the fundamental operations that we understood about working with Docker Swarm or the Docker cluster. And then we also saw about Docker service, where we first understood about the Docker service architecture, where we saw different components which are available in the Swarm manager, and then we also had certain components in the Swarm worker. And also we saw that how those components were able to communicate with each other, where the worker was communicating with the dispatcher component of the Swarm manager. So these were some of the concepts that we understood from the Docker service architecture. And finally, we also did a hands-on with the Docker service by creating a service which also created the containers. So using a single command, we were able to create multiple containers, and also using the single command, we were able to remove or delete all the containers. So which means that basically we were able to manage our containers lifecycle using the service based on which those containers got created. And finally, we also looked at how we can scale up or scale down our service by using the replica keyword. So I hope that all the concepts were clear and it was easy to understand. From here, you can reference Docker documentation in order to further dig all these concepts that we have understood. And also you can pull more and more images of different applications from the Docker Hub account or your public repository, and you can install them in your test lab and practice more and explore more about Docker. So here we are concluding this Docker training module, and I really appreciate that you have been able to complete this training module. So see you in another training module in the future. If you like this video, then hit that like button, share it with other code lovers, and also subscribe to CodeFramer for more videos. Thank you and see you next time.